Among the 8 planets of our solar system, Jupiter is the ultimate outlier. It simply doesn't fit in. It is the behemoth of planets, boasting a mass 2.5 times that of all other planets combined, and a volume capable of swallowing over 1,300 Earths. As the eldest sun of the solar system, Jupiter is also the planet most similar in composition to the Sunday. But here's a fact few people know. Jupiter once had the chance to become a real star. So, what exactly caused Jupiter's evolution to fail? What consequences did this failure bring? And is there any possibility that Jupiter could still be ignited to become a new star? In this video, we will explore Jupiter's legendary journey from star candidate to planetary overlord. To understand why Jupiter failed, we first need to know how stars are formed. The essence of a star is a celestial body that continuously radiates energy through nuclear fusion in its core. Under long-term gravitational disturbance, matter in a primordial nebula gradually gathers in a core region. Just like a storm system on Earth, it spins and compresses endlessly, causing the mass and density of this core to grow larger and larger. The more mass it has, the more matter it attracts, finally forming a stellar embryo. When its temperature and pressure break through the critical conditions for fusion, its center ignites, and a brand new star is born. In fact, in all the galaxies humans have observed so far, binary or multi-star systems make up the majority. This means these systems usually have 2 or more stars, unlike our solar system, which is a one-man show for the Sunday. This is because the distribution of matter in the nebulae that birth stars isn't even. There are often multiple core regions. So, why did our solar system only produce one star? The Sun, 4.6 billion years ago. The solar system was a vast and beautiful nebula with a diameter of 1 to 2 light years. In this nebula, no celestial bodies had been born yet. There was only endless gas and dust. The solar nebula at this time was like a star boot camp, where all matter was rapidly rotating and condensing, making final preparations for the birth of a star. In its early formation, Jupiter was an absolute star trainee and was once the celestial body with the highest hope of becoming a second sun. Scientists speculate that early Jupiter worked very hard. Its mass grew at an astonishing speed, and at one point, it likely came very close to the critical mass for a star. Unfortunately, in this star debut competition, the disparity in strength between Jupiter and the Sun was just too wide. Although they both likely occupied core regions in the nebula, the Sun undoubtedly grabbed the more favorable position, leading to a massive difference in their growth speeds. As the sole lister of the solar system, the Sun's growth speed was ridiculously fast. According to scientific estimates, from the gravitational collapse of nebular matter to condensing into a star, the Sun took only about 1 million years to successfully claim the center stage. While Jupiter was still struggling to absorb nebula dust, the Sun had already successfully triggered its own nuclear fusion, growing into a true cosmic superstar. At this moment, the Sun was full of ambition and radiating endless light. Its unrestrained brilliance served as a harsh reality check for Jupiter, who was trying to catch up, completely cutting off the possibility of Jupiter becoming a second star. The solar wind quickly blew away the surrounding hydrogen and helium gas, causing Jupiter, located just 3.5 astronomical units AU away, to lose its massive source of material. Jupiter's growth came to an abrupt halt. According to astrophysical theory, For a celestial body to become a star, even the smallest red dwarf its mass needs to be at least 8% of the Sun's mass to successfully trigger fusion. However, the Sun, having just debuted in the center spot, pulled up the ladder behind it, leaving no chance for Jupiter. Like a glutton, a mythical beast that eats but never releases, the Sun used its powerful gravity to frantically devour 99.86% of the total mass of the solar system. The meager leftovers had to be shared among other planets, asteroids, and celestial bodies. Even though Jupiter had the first mover advantage, no matter how hard it tried, it couldn't plunder the entire solar system like the Sun did. Furthermore, besides external interference, Jupiter's own composition was a key factor in its failure. Scientists speculate that early Jupiter had a solid core, likely made of metal or rock. Although this core was massive enough to generate strong gravity to attract surrounding matter, it also limited the rise of Jupiter's internal temperature and pressure. Even if Jupiter gathered more matter, it would be difficult to create the extreme environment in the core needed to ignite nuclear fusion. So, with the Sun blocking the way ahead and other planets competing behind, Jupiter, with its inherent deficiencies, could only swallow its regret under the pressure of both. Although Jupiter failed its debut, its immense power is not something other planets can mess with. Jupiter's mass is only 0.1% of the Sun's, yet it is 2.5 times the sum of the other 7 planets and 318 times that of Earth. However, as the loser of the star debut competition and the giant among planets, Jupiter didn't just grow quietly in place. Instead, it acted like an interstellar pirate, becoming the biggest spoiler in the early solar system. In observing exoplanetary systems, scientists found that planets elsewhere are more balanced in mass, volume, and spacing, making our solar system look like the odd one out. To explain this strange phenomenon, scientists proposed a theoretical model called the Grand Tack. This hypothesis suggests that Jupiter was not born in its current orbit, but at a distance of 3.5 AU from the Sun, about half its current distance. Filled with resentment after its failure, driven by gravity and gas movement, Jupiter decisively set sail, moving against the current and charging straight toward the Sun without looking back. Jupiter was like a warrior, wielding 2 machetes, slashing its way through, turning the system upside down. It smacked a massive number of asteroids out of the inner solar system. The rocky material that luckily escaped clustered near the orbits of Earth and Venus, providing enough raw material for these 2 planets to grow. But Mars wasn't so lucky. Under Jupiter's unreasonable plundering, Mars was left shivering in the corner. Managing to get even a bite to eat was hard enough, let alone acquiring more resources. This led to Mars being congenitally underdeveloped, with a very small mass and volume. Scientists speculate that without Jupiter's aggressive interference, Mars should actually have been larger than Earth. If Jupiter had continued drifting toward the Sun, the future Earth would have been in grave danger. But eventually, Jupiter stopped at 1.5 AU from the Sun, near the current orbit of Mars. As the second planet born in the system, its good brother Saturn saw that big brother Jupiter was going to fight the Sun to the death and stepped in to stop it. At this point, Jupiter and Saturn formed a 1:2 orbital resonance. Under the combined influence of their gravity, they held hands and started running outward. Having been charging forward majestically only to be pulled back, Jupiter became furious and its temper grew even worse. As it crossed the asteroid belt again, Jupiter flung a massive number of small celestial bodies toward the inner solar system. These meteors, big and small, smashed into the 4 terrestrial planets like cannonballs for hundreds of millions of years, a period known in astronomy as the Late Heavy Bombardment. The pockmarked face we see on the Moon today was caused by Jupiter's pounding back then. It is precisely because of the Moon's protection that Earth didn't suffer a devastating blow. Moreover, these element-rich meteorites brought essential substances for life to Earth, providing more favorable conditions for life's origin. However, Mars and Venus, lacking satellite protection, were out of luck. Jupiter's crazy behavior brought catastrophic consequences to them, likely directly altering their structural states, interrupting their evolutionary processes, and turning them into what they are today. Imagine, without Jupiter's 2 interference events, Mars might have been just like Earth today, not only similar in size, but also with a high probability of birthing life. Even if it hadn't evolved advanced beings like humans, Mars could have been a much more habitable environment, making human migration to Mars much simpler. Not only that, but Jupiter's shuttle run seriously affected the layout of planetary orbits. We now see Uranus inside and Neptune outside, but when they formed, the situation might have been reversed: Neptune inside, Uranus outside. The reason is that during Jupiter's outward migration, Neptune was pushed further away by Jupiter, ending up outside Uranus. Also, Jupiter's own position is quite eerie. The distances between the 4 inner terrestrial planets are very balanced, but the gap between Jupiter and Mars is almost double that distance. Scientists speculate that there might have originally been another planet between Jupiter and Mars, but under Jupiter's influence, this planet either failed to form, was torn apart by Jupiter's gravity into the asteroid belt, or more directly, was thrown out of the solar system by Jupiter and stripped of its planetary citizenship. Finally, upon reaching 5.2 AU from the Sun, Jupiter's orbit stabilized. The settled Jupiter seemed to calm down, its anger subsiding. It stopped being the spoiler and transformed into the guardian of order. In multi-planet systems, gravitational interactions can easily lead to orbital chaos, collisions, or ejections. But in the solar system, Jupiter acts like a massive anchor, balancing the entire gravitational field so that other planetary orbits remain stable for the long term without drastic shifts. This stability is a crucial prerequisite for life, because if orbits change frequently, surface temperatures and atmospheres fluctuate wildly, making it impossible to form a habitable environment. More importantly, Jupiter's powerful gravity acts like a whirlwind blade, tearing apart, capturing, or deflecting countless asteroids and comets, greatly reducing the threat to Earth. Scientists calculate that without Jupiter, the probability of Earth being hit by small celestial bodies would increase by 1,000 times. Impacts similar to the one that wiped out the dinosaurs might have happened many times. Jupiter's great interstellar drift after its failed evolution not only shaped its own unique system, but also profoundly influenced the formation and evolution of other planets. For humans and Earth, the current Jupiter stands guard like a gatekeeper, providing the strongest guarantee for the proliferation and evolution of life. After billions of years of evolution, Jupiter has become one of the most mysterious and unique planets. As the earliest formed planet, it is also the largest. Its diameter exceeds 140,000 kilometers, about 11 times that of Earth, and its interior could hold over 1,300 Earths. Unlike the four rocky planets, Jupiter is a gas giant with no solid surface, composed roughly of 71% hydrogen, 24% helium, and 5% other elements. Jupiter boasts the largest planetary atmosphere, over 5,000 kilometers thick, with pressure at the bottom reaching 2 million times Earth's standard atmosphere. Under this extreme pressure, hydrogen is compressed into a liquid or even solid state, forming a solid-liquid mixture resembling porridge. Although it failed to become a star, Jupiter seems to have kept a star dream. If it can't play with planets, playing with moons will do. Jupiter not only has the most moons, but their strangeness rivals any planet. These moons form a unique planetary system like a miniature solar system. As of April 2025, scientists have discovered 97 Jovian moons, and this number is likely to grow. The most famous are the four discovered by Galileo in 1610: Io, Europa, Ganymede, and Callisto. Ganymede, with a diameter of over 5,200 kilometers, is larger than Mercury and is the largest moon in the solar system. All four possess rare geological structures. Ganymede and Europa have global liquid oceans beneath their solid surfaces, making them the most likely places for extraterrestrial life. Io is the most volcanically active body in the solar system, while Callisto is one of the oldest, forming almost simultaneously with Jupiter. Callisto lacks obvious geological activity, preserving primitive information from the early solar system. How they became Jupiter's moons is still debated, perhaps formed naturally nearby or grabbed by Jupiter during its drift. After all, with Ganymede's size, it could have been a planet itself. Beyond these four, Jupiter has many small moons, mostly captured asteroids or comets. Orbiting Jupiter, they form a structured, complex mini-solar system, as if telling the story of Jupiter's unwillingness to give up, serving as a microcosm of the solar system's formation for scientists to study. It has been 4.6 billion years since the Sun's birth. On a cosmic scale, the solar system is still young. So, in the foreseeable future, is there any chance for Jupiter to ignite and become a real star? As mentioned, a star needs at least 8% of the Sun's mass to trigger fusion. That's about 80 times Jupiter's mass. The total mass of the solar system, excluding the Sun and Jupiter, is only 40% of Jupiter's mass. Even if Jupiter went crazy and swallowed every other planet, it wouldn't be enough. The vast majority of mass is in the Sunday, so to gain weight, Jupiter needs the Sunday. Scientists calculate that in about 5 billion years, the Sun will enter its old age and expand into a red giant, throwing matter into the universe and losing 1/3 of its mass. This would be Jupiter's best chance. But even if the aging Sun sends a big gift, can Jupiter catch it? First, the Sun ejects matter in all directions. Jupiter's gravity is strong, but catching this diffuse spray is like trying to catch rain with a cup. It will get very little. Second, even if the Sun fed Jupiter precisely, Jupiter might not hold it. The red giant Sun will reach beyond Earth's orbit. Being closer, Jupiter will be roasted. the hydrogen and helium in its atmosphere will escape. Jupiter would be like a leaky bucket, losing more than it gains. Accretion is impossible. What about external force, like a massive explosion? Unfortunately, no. Jupiter's structure is unique, a core wrapped in liquid metallic hydrogen and a super thick atmosphere. The energy of an external explosion would decay rapidly through the layers, never reaching the core. We have a real-life example. In July 1994, comet Shoemaker-Levy 9 was torn apart and slammed into Jupiter. This was the first extraterrestrial collision humans directly observed. The largest impact released energy equivalent to 6 trillion tons of TNT, about the same as detonating 100,000 Za-bomba hydrogen bombs simultaneously. Although it blasted a hole larger than Earth in the upper atmosphere, the depth only reached the middle cloud layer, let alone the core. Furthermore, while the explosion's temperature was extreme, it was brief. To sustain fusion, you need to maintain over 10 million degrees Celsius long term. Using an explosion is like trying to light a log with a match, theoretically possible, but practically impossible. Therefore, the moment the Sun graduated from star boot camp, Jupiter was destined to be just a planet. Its ultimate fate is likely to continue orbiting the white dwarf Sun, its dream forever unrealized. But let's imagine, what if 4.6 billion years ago Jupiter had won enough matter and became a star? What would a two-sun system look like? If a ship has two stubborn captains, the passengers get thrown around. The same applies here. If Jupiter were a star, the planetary orbits would be completely overturned. Under the gravity of two stars, stable orbits would become complex eccentric ones, or even cross paths. Planets orbiting the binary stars would move erratically like drunkards. Closer planets might be swallowed or ejected, and others might collide. Asteroids and comets would run wild, causing frequent impacts. Under the radiation of two stars, the climate would be catastrophic. If Earth orbited both when between them, it would face maximum radiation from both sides. No night, only endless day. The atmosphere would be stripped, temperatures would skyrocket, oceans would evaporate, and the surface would be destroyed. When outside both stars, Earth would freeze in darkness. Liquid water couldn't exist, and Earth would be a planet of death, not a cradle of life. The solar system would become a chaotic carnival of celestial bodies, planets tearing at each other, asteroids shuffling wildly. Jupiter's failure is both a regret and a blessing. For Jupiter, the dream is gone. But for Earth and humans, stability comes from that failure. Order and balance are prerequisites for life. Although Earth is a drop in the cosmic ocean, it is our chosen land. When we look up at bright Jupiter, thinking of this cosmic regret and luck might give us a deeper understanding of life.